Okay, ladies and gentlemen, let's have a look at our Roland Modela MDX40-A CNC. This is actually a high precision milling machine. It's manufactured by Roland, the same Roland company that you're probably familiar with for their musical, namely their keyboards, their musical equipment, very large electronic conglomerate, and they do have a wing of their division that is focusing on this type of machinery as well. Unlike our 3D printers, which are additive manufacturing, this particular device and CNCs, computer numeric controlled devices, are actually subtractive manufacturing. And I pulled up an example of David to kind of show us what exactly that means. This particular model of David was done in our 3D Systems 460 powder printer, and so it was printed only where needed on the X as it went up. The loose powder was around it, and that was all vacuumed away, so there was essentially no excess material there. This David was actually done in this Roland MDX40-A. If you notice, it requires a blank, and I like to use the analogy of Michelangelo actually creating the first David. He took an enormous block of marble and simply carved away what wasn't David. And that's really what the CNC did here. Now, as a result, you are left with an immense amount of wasted material. But there are cases where the subtractive manufacturing is definitely a very compelling option. So this is something to keep in mind. And the good thing is this is a very high precision milling machine. The Roland runs about $4,600, and this particular model does cut a variety of materials: plastics, acrylics, plexiglass, foam. This is a hard density foam actually up here, wood. It even cuts copper and aluminum, although we have not focused on that much just because it's a very time consuming process. This doesn't have really high RPMs. So it does have the capability though. The other nice thing about this machine is it actually has two types of cutting options. And the two that are available are the usual 3-axis. So this would be the bed that would go into the machine to cut a 3-axis. So that would be the X and the Y, and then the bit itself would be the Z. We also purchased the 4th-axis option, and what that is it's this device here. It's essentially if you think of like a rotisserie, and so now you have the X and the Y and the Z, and this rotisserie, the roller, they call that the A-axis. And so you can get essentially a 360 or a top and a bottom cut. That is a very compelling option because trying to align apart top and bottom on a flat bed like this can be very, very difficult. Now, the 3-axis has its own wonderful purposes. This is an example. This is a Spartan, go Spartans. It's cut out. This is a topography that was cut out. You also can do the top and the bottom like David was. Now you see that there were supports that were put in here, top and bottom. But I'm going to try to zoom in and show you. Do you notice that as a result of this, we lost the detail on certain portions because it didn't mill all the way through. This is flat here, for example. And if you were to look at it from this view, obviously, and this view, there would not be any detailed cut. I mean, it didn't do a bad job, but it's not cut all the way through. So there he is. So another option that you can do is you can actually do a cylindrical piece, or even take a rectangular shaft and basically tell the machine that you're cutting it in a diameter so that it will rotate as a 360 and you can cut an entire circular pattern, or cylindrical pattern. So here's some examples. Geometric shape, Coca-Cola bottle. This is a D&D figure. A couple more. This is Miley, our summer intern. So you can see she actually has her mask on in this. This was a distorted scan of a colleague. So you can play with the software. This is Christopher. So you get a sense of some of the very high resolution that can come off this machine and the variety of models that can be made in a variety of different methods. The size constraint on the 3-axis is, it's a 10 by 10. And depending on the size of the blank that's going on it, you've only got a couple inches of clearance. So that's a bit of a constraint that needs to be kept in mind. With the 4th axis put in, you have about 11 inches from end to end. And then depending on the rectangular shape or the cylindrical shape of your part, or your blank, excuse me, you have a couple inches in both the Y and the Z to work with, because you have to be able to clear these support bars as your blank is rotating. So there is a little testing and calculating that needs to go on there. So the bit is back here, currently has a 16th inch bit in it, and there is a collet that holds that in, and then obviously the motor assembly is here. It takes two different types of collets, two different sizes. This is a 1/4 inch, and then this is an 1/8 inch collet here. So these are the two. It will not take a bit larger than a 1/4 inch bit. And we do have all the way down to a 64th inch bit. So we've got a toolbox full of different size bits. So also flatheads, bull nose, a variety of different shapes to have some real specific cuts made, which is quite nice. And the software enables us to do multiple cuts, multiple passes. So you could do, let's say, a rough cut with your 1/4 inch bit, and you could work your way down all the way to a 64th inch high detailed finishing pass. So really get some high definition in that. The software that is required is, there are actually two softwares that are specific to this Roland. This is the V panel, and this actually is to control the actual hardware, the machine itself. Here you see this is the bit, the exact location, control panel to actually rotate that and to send it to locations. So this is how we would manually prepare our origin against the blank that we are cutting. Now, to actually load the model, this is what's called the SRP player. And so this is the x-axis. We would put our blank kind of on that line and then load our model in there. One of the very compelling pieces of this particular CNC is it actually takes STLs, those standard tessellation language file types, just like a 3D printer does. Most subtractive manufacturing, most CNC machines require a CAM software to convert a CAD model. CAM is computer-aided machining. And so you would actually need to, you, the user, convert your CAD model into a G code, whereas this software will translate your STL, just as you've saved it for 3D printing, into that G-code itself. So this is a really compelling part. We don't have to have that additional expertise and knowledge in CAM. And so here in the SRP player, it will do all of that for us. So let's go ahead and find a blank and choose a model and get to milling it.